A very good afternoon to all of you. This is your friend Jatin from Pariksha Expert ePathshala. Now in today's video we are going to discuss about chapter number 8, the application of integral. I have taken a screenshot of the rationalized syllabus as provided by CBSE. You can find the link of the website down in the description box. Now according to this, if we can see, the area of region bounded by a curve and a line has already been rationalized by CBSE. It means that we are not going to study this topic. Similarly, from exercise 8.1, we are not doing question number 3, question number 6 to 11. It means in this video, we will be looking at the question number 1 of exercise 8.1, question number 2. So let's directly jump to the questions. Now exercise 8.1, question number 1 says, find the area of the region bounded by the curve y square is equal to x. Y square is equal to x means it is a parabola. And the lines x is equal to 1 and x is equal to 4 and the positive x-axis in the first quadrant. It means what we can do is we can directly plot the parabola. This is our axis. We have x-axis and y-axis here. If we can plot y square is equal to x, it will be something like this. And then we have to find the region, find the area within the region x is equal to 1 and x is equal to 4. Let us say this is my x is equal to 1 and this is my x is equal to 4. So it means we have to find the area lying beneath this red lines. Also, we have to consider that only positive x-axis is to be taken here, not the negative x-axis. It means the overall region, the overall area that we have to find is this. Now, as we know that in application of integrals, we have to do the integration of y dx where the limits are of x. So here it is given from limit 1 to 4. Means the question will be now, we have the equation as y square is equal to x, or we can say that y is equal to root of x. So therefore we will integrate root x dx and the limits will be from 1 to 4. Hence we can see root x means x to the power of 1 by 2. Integrating this from 1 to 4 dx, we will have x to the power of 3 by 2 whole upon 3 by 2, where the upper and the lower limits will range from 1 to 4. Hence we can say that taking 2 by 3 outside is common, we will have x to the power of 3 by 2 and the limits range from 1 to 4. Solving this further, we will have 2 by 3 x to the power of 3 by 2. It means we are going to write first the upper limit. पहले upper limit लिखेंगे. Power is 3 by 2 and then we will subtract by taking the lower limit. This is something that we have already done in definite integrals. Hence 2 by 3. Now 4 to the power of 3 by 2. First we will find 4 to the power of 3. That makes 4 4s are 16, 16 4s are 64 and 64's square root is 8. So therefore 8 minus 1. This we will get is as 2 by 3 into 7 or 14 by 3 square units. Please don't forget the unit. Next is question number 2 of exercise 8.1. It is also of the same type, and it says find the area of the region bounded by y square is equal to 9x. Again, it is a parabola, and the lines x is equal to 2 and x is equal to 4 with positive x-axis. So again, let us first plot the parabola. I have taken the axis here, and the parabola will be something like this, where the equation is given as y square is equal to 9x, and the lines are x is equal to 2. Let us take this as x is equal to 2 and x is equal to 4. It means the area that we have to find will lie in between these red lines. But it also says that we have to find the area only in the positive direction of the x-axis. It means we have to consider this area. So the integration will be of y dx, and the limits will range from 2 to 4. Hence, we can say that this is square root of 9x integration 2 to 4 dx, or we can also say that this is 2 to 4 integration of root x dx. Now root x can be written as, if 3 is constant outside, integration of root x will be x to the power of 3 by 2, 3 by 2, and the limits will range from 2 to 4. Hence, we can just simplify it as x to the power of 3 by 2 upon 3. 2 can be written here, where 3 and 3 will cancel out, and the limits will be now x to the power of 3 by 2 from 1 2 to 4. We have already done this in the definite integrals, how we solve these limits. The first thing that we have to take is we will substitute first the upper limit. It means 4 to the power of 3 by 2 minus 2 to the power of 3 by 2. 4 to the power of 3 by 2 can be written as 4 cube, means 64, means the square root of 64, that will make 8 here, minus 2 cube is 8 and square root of 8 is, let us take root 8 only. Hence, what we can get is 16 minus root 8 square units. I hope the question is clear.